In this video, I want to talk about Bayes' theorem. So we're going to talk about Bayes' theorem in general. And what I want to do in order to derive Bayes' theorem is first remind you a little bit about conditional probability. So recall that the probability of A given B means what's the probability that A happens given that we already know B occurs, is the probability of A and B divided by the probability of B. And likewise, if we were to reverse the role of A and B, if we want to find the probability of B given A, then that's still going to be the probability of, let me be consistent here, B first, B and A, divided by the probability of A. Now, what turns out to be the case is that if you think about these as sets, it turns out that A and B is going to be the set of events where A and B happen, and so the order is not going to matter. B and A is the same as A and B. And so what that tells you is that these two quantities are going to be equal. And what I want to do then is I want to take each equation and solve for that quantity. And then since they're equal, we'll see what happens. So this means that the probability of A and B is the probability of A given B. And then we're going to take this term and move it over. So that's the probability of A given B times the probability of B. Likewise, the probability of B and A is the probability of B given A times the probability of A. Okay, now, like we just said, these two are the same set, and therefore they have the same probability, and then that means that the other two parts of this equation must be equal. So therefore, this is Bayes' theorem. So this gives us Bayes' theorem, which is the statement that these two quantities on the right side of each equation are equal. We know that the probability of A given B times the probability of B is the same as the probability of B given A times the probability of A. Or equivalently, another way to write this is that you could say that the probability of A given B is the same as the probability of B given A times the probability of A divided by the probability of B. All right, what I want to do is let's consider an example. And what I want to do is I'm going to just put up a probability tree diagram with, I don't care what the events are, make them whatever you want. But what I want to do is I want to have more than one event. So let me just explain. So suppose that we have some event or some experiment where we have a few different outcomes. So let's say we have, let's call these A's, A1, A2, A3. Those are the things that can happen first. So just say one of three things. So maybe A1 happens with probability 0.5, A2 happens with probability 0.1, A3 happens with probability 0.4, because we know that all of those have to add to 1 if those are the only possibilities. And then after A1, A2, or A3 happen, either B or C happens. Okay, so let's call this B or C. B, C, B, C. And then maybe the probabilities here are 0.7 and 0.3, 0.4 and 0.6, and 0.2 and 0.8. Okay. Bayes' theorem is where you want to figure out what's the probability of, say, A1 given C. So we want to find the probability of A1 given C. And so what we're going to do is we're going to use a Bayes' theorem. This seems somewhat backwards, right? Because if A1 happens first, so it seems just slightly backwards, but there's good reasons where this is useful. And we'll talk about a medical example where this is going to be super useful for us. So let's apply Bayes' theorem. The probability of A1 given C is going to be the probability of C given A1 times the probability of A1 divided by the probability of C. And these numbers are perfectly easy to find, almost. The only one that's going to be a little tricky is the probability of C. And in order to compute the probability of C, what we have to do is we have to think about what are all the ways that C can happen. And C can happen by first A1 happening, first A2 happening, or first A3 happening. So there's 3 different ways that C can occur. And then what we're going to do is we have to add up all those probabilities. So this is the probability of, so the probability of C, let's first copy our numerator. But the probability that C occurs is going to be the probability of C given A1 times the probability of A1 plus the probability of C given A2 times the probability of A2 plus the probability of C given A3 times the probability of A3. Just barely fits. Okay? And the book likes to write this as the probability, so this is the probability of C given A1 times the probability of A1 divided by the sum of the probabilities of C given AI times the probability of AI. So that's the way that the book likes to write Bayes' formula, is probability of A1 given C has this kind of complicated looking formula. It's really not that complicated. It's just that in a tree diagram, you have to be very careful about how you compute the probability that C occurs. So now at this point, let's plug in all the numbers that we have. And I'm going to zoom out slightly so we can see all the numbers. And I'll zoom back in once we have all them put down. So what we're going to do is we're going to, in the numerator, do the probability of C given A1. So the probability of C given A1 is going to be our 0.3. The probability of A1 was 0.5. So the probability of C given A1 is 0.3 here. I think I made all the numbers different, so it should be clear where everything is coming from. So that's good. The probability of, oh, well, I guess these two numbers are the same, but can't be perfect. So, so anyway, so that's the numerator. In the denominator, we're going to get the same probability of C given A1. So that's 0.3 times 0.5. Now the probability of C given A2, so that's going to be 0.6 times 0.1 plus the probability of C given A3 is 0.8 times the probability of A3 is 0.4. And if we multiply all these out, we're going to get 0.15 divided by 0.15 plus 0.06 plus 0.32. So altogether, that's going to be 0.15 over, let's see, 15 plus 6 is 21, plus 32 is 53. And so altogether, the probability of A1 given C is going to be 15 over 53, whatever that turns out to be as a decimal. So there's our probability of A1 given C. This is Bayes' theorem in a nutshell. In our next video, we'll do an example where we're going to talk about an actual medical diagnosis, one place where this is actually incredibly useful to understand Bayes' theorem.